Let's say you're an engineer and you just got paid some money to start a building project right here in Times Square. Now this building is not a perfect rectangle, as you can see, and in order to give the construction team accurate measurements, you need to know this particular angle right here. You don't have the time to go measure it yourself, but you know two facts. One, these streets right here are parallel. Two, you actually worked on this building last year and you have the angle in file. This angle is 105 degrees. Now, do you have enough information to find out your angle of interest? My name is Xinhui, and let's talk about angle relationships created by parallel lines and transversals. Parallel lines are lines that never intersect each other, and transversals are lines that cross two or more parallel lines. First, we'll discuss why we care about this math topic and why it's always one of the first big topics you learn in geometry class. Second, I'll teach you an easy way to remember the names of all the angle relationships, and then you'll get a chance to practice. Lastly, we'll discuss the math properties of these angle relationships and do some more practice. Okay, why do we care about parallel lines and transversals? Lines and the angles they make are the foundation of geometry, which is a branch of math, and geometry is the foundation of structures. We all live in structures, whether it's the layout of a city, its infrastructure, a building, or your furniture. We're able to engineer these things because of geometry, and the vast majority of them, as you can see, involve parallel lines and transversals. So we want to know how the angles are related to each other in setups with parallel lines and transversals. Next, we're going to talk about an easy way to memorize angle relationships created by parallel lines and transversals. A problem can give you two angles and ask you, how are they related? To answer that, just ask yourself these two questions about the two angles. 1, are they on the same side or alternate sides of the transversal? 2, are they on the interior or exterior of the two parallel lines? Here's our catalog of angle relationships. If two angles look like this, they are same side interior angles because they're on the same side of the transversal and they're both inside the parallel lines. Same side exterior angles are on the same side of the transversal and both outside the parallel lines. Alternate interior angles, alternate sides of the transversal and inside the parallel lines. Alternate exterior angles, alternate sides of the transversal and both outside the parallel lines. And finally, there's a fifth type, corresponding angles, when they're on the same side of the transversal, but one is on the interior and the other is on the exterior. Let's practice naming these angle relationships now. We're going to do an example together. Number 1, angle Y and angle X. They're on the same side of the transversal and they're both inside the parallel lines. So I'm going to write they are same side interior angles. Alright, now you can pause the video and try naming number 2 to 6 on your own. Let's talk about the solutions. Number 2, my angles are on the same side of the transversal and both outside the parallel lines, so they're same side exterior angles. Number 3, my angles are on the same side of the transversal and one is outside, one is inside the parallel lines, so they're corresponding angles. Number 4, these two are my parallel lines and this is my transversal, so my two angles are on alternate sides of the transversal and both outside the parallel lines, so they're alternate exterior angles. Number 5, my two angles are on the same side of the transversal. One is outside and one is inside the parallel lines, so they are corresponding angles. Number 6, my two angles are on alternate sides of the transversal and both inside the parallel lines, so they are alternate interior angles. Alright, finally, we're going to talk about the mathematical properties of these angle relationships. Same side interior angles are supplementary, meaning that they add up to 180. Same side exterior angles are also supplementary. Alternate interior angles are congruent, meaning they're equal. Alternate exterior angles are also congruent. And finally, corresponding angles are congruent as well. Now let's practice finding the actual angle measures. So same thing, we'll do an example together first. Number 1, step 1, we're going to identify the angle relationships. So these two angles, they're on alternate sides of the transversal and both inside the parallel lines. So they're alternate interior angles, meaning that they're equal. So the missing angle has to be equal to 84 degrees. Cool. So now I encourage you to pause the video and try number 2 to 4 on your own. Let's work through the solutions together. For number 2, this is an alternate exterior angle. So they are congruent, meaning that this angle right here is 47 degrees. Number 3, these are same side interior angles, meaning that these two angles should add up to 180 degrees. So 100 plus question mark is 180 degrees. This means that question mark has to be equal to 180 minus 100 degrees, which is equal to 80 degrees. Number 4, these are corresponding angles, so they have to be equal, which means that this angle right here is 105 degrees as well. So we actually found the angle for our new building. It is 105 degrees. To recap, we started with a real-life problem involving angles created by parallel lines and transversals. Then we talked about why we care about this topic. Then we learned and practiced identifying the angle relationship names. And finally, we practiced solving geometry problems with missing angles created by parallel lines and transversals. Thank you so much for watching this, and good luck working with parallel lines and transversals in the future.